On this 2019 to 2025 Ram 2500 HD with the 6.4HEMIGas engine, P0304 means the PCM is seeing a possible misfire on cylinder 4. The truck may run rough, hesitate, shake, or turn the MIL on, and if the misfire is severe, the MIL can flash. Broadly, this can come from possible ignition, fuel, air, mechanical, oiling, VVL, wiring, or PCM control issues, so don't jump straight to a part. Start with the basic system checks, then make sure the misfire monitor is actually allowed to run. Treat the running conditions as monitor gates: fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 4 degrees F, or enabled when engine temperature reaches 21 degrees C, 8 degrees F, and engine speed between approximately 400 RPM and 6,200 RPM. The code sets when crankshaft speed variation between cylinders exceeds a calibrated value based on engine speed and load. If this truck has stop/start, that system will be disabled while this code is active. First, turn the ignition on and use the scan tool to read and record all DTCs and the captured operating data. Drive or operate the vehicle under the same captured conditions from when P0304 set. During that road test, pay attention to when the misfire shows up, because that matters later. When the misfire is happening, watch the downstream O2 sensors and open the misfire monitor to see which cylinders are being counted. If cylinder 4 is showing excessive misfires right now, continue with this path. If it is not active, handle it as an intermittent condition instead of forcing the rest of the test. Next, look at the DTCs you recorded. If there are active or pending faults in the fuel system, ignition system, air handling system, VVT system, or VVL system, diagnose those first because they can drive the misfire. If there are no supporting active or pending codes, move into the inspection. Look for obvious load and engine issues: a worn belt, accessory pulleys that are misaligned or binding, incorrect sensor mounting, poor connector or terminal contact at the crank sensor, cam sensor, MAP sensor, throttle body, fuel injector, ignition coil and related components, corroded PCM powers or grounds, vacuum leaks, restricted intake or exhaust, signs of internal engine trouble, moisture on ignition parts, insufficient or poor fuel, manual transmission bogging or towing overload. If you find a problem here, repair it and then verify the repair before going deeper. If the inspection does not find the problem, check the engine and intake manifold for vacuum leaks. Any intake leak you find gets repaired, then the repair gets verified. If there are no intake leaks, check fuel quality and fuel supply basics: water in the fuel, wrong fuel type, old or contaminated fuel, and low fuel. Also check for proper ethanol level in the gasoline. If the fuel is the issue, replace the fuel and, if needed, flush and clean the fuel system, then verify the repair. Before working on the fuel system, remember it stays under constant pressure even with the engine off. Release fuel pressure before testing or servicing any fuel hose, fitting, or line. For the injector check, install fuel pressure decay tester 8978A to the fuel rail. Turn the ignition on. Let fuel pressure reach maximum and stabilize, and record that as the starting pressure. With the scan tool, actuate the fuel injector for cylinder 4 while watching the gauge, then record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder. Skipping that can damage the engine. Repeat the same test on several good cylinders, always starting from the same starting pressure, and compare the ending pressures. If cylinder 4 ends about the same as the known good cylinders, keep going. If cylinder 4 stands out, a small pressure drop points you toward debris in the fuel rail or injector, and a large pressure drop makes a faulty or fouled injector suspect. Repair what you find and verify the repair. If injector flow looks comparable, turn the ignition off, remove the fuel pressure decay tester, and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 4, reconnect the coil connector, disconnect that cylinder's fuel injector connector, install a spark tester, and crank the engine. A crisp blue spark sends you to plug and cylinder checks. No crisp blue spark sends you to the ignition circuit checks. With spark present, remove and inspect the spark plug. Look for cracks, carbon tracking, oil, coolant, excess fuel fouling, an incorrect gap, or a loose or broken electrode. Also look for oil or coolant in the cylinder. If the plug has those faults, replace the spark plug. If oil or coolant is in the cylinder, diagnose and repair the cause, then verify the repair. If the plug and cylinder look clean, run a compression test on all cylinders and compare cylinder 4 to the known good cylinders. If compression is not within specification, do a cylinder leak down test to separate valvetrain from combustion chamber causes, repair as needed and verify. If compression is within specification, swap the spark plug with a known good cylinder, or replace it if access makes swapping impractical, then run the engine and watch the misfire monitor. If the misfire follows the plug, replace the spark plug. If it goes away after plug replacement, the repair is complete, but still verify it. If the misfire does not follow the plug or go away, decarbon the valves and combustion chambers using Mopar combustion cleaner. After driving and clearing the cleaner from the engine, erase the DTCs, test drive under the captured conditions, and watch the misfire monitor. If the misfire does not return, the cleaning fix the fault and you verify the repair. If it returns, check engine oil level and condition before going farther. Look for mechanical tolerances out of specification, oil pressure out of specification, low oil level, an oil filter that does not meet OEM specifications, dirty or deteriorated oil, contaminated oil, incorrect viscosity, or aerated oil. If you find an oiling or mechanical problem, repair it, including causes such as improper oil drain back, oil sludge, damaged oil pump, pickup tube, or seal concerns. Then verify. If those checks pass, and the misfire occurred when engine speed exceeded 5,000 RPM and VVL is suspect, check VVL operation. With no oil flow and the solenoid off, the rocker arm should be in high lift mode. A rocker arm stuck in low lift can cause a high RPM misfire at or above approximately 5,000 RPM and may not set a VVL system code. Before checking rocker arms, make sure the solenoid O-rings are not missing or damaged and that the solenoid is not leaking when off. If no VVL issue is found, visually inspect the camshaft, rocker arms, and springs for excessive wear or broken parts. Repair any issue found and verify the repair. If none are found, move to the related harness and connection checks. If the spark test did not show a crisp blue spark, go after the coil power and control circuits. Keep clear of the fan, belts, and pulleys anytime the engine is operating, and do not wear loose clothing around them. Turn the ignition off, disconnect the ignition coil connector, turn the ignition on, and actuate the ASD relay with the scan tool. Using a 12-volt test light connected to ground, probe the ASD relay output circuit at the ignition coil connector. If the light does not illuminate brightly, stop all scan tool actuations and repair the open or short to ground between the PDC and the ignition coil connector, then verify the repair. If the ASD output is good, use a 12-volt test light connected to a 12-volt source and back probe the coil control circuit at the ignition coil connector. Crank the engine for 5 seconds while watching the light. If it blinks brightly, replace the ignition coil and verify the repair. If it stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCMC2, install the GPEC Diagnostic 10436 adapter on the engine harness side, and check continuity between ground and the coil control circuit. Do not probe PCM harness connectors directly. That can damage the terminals and create a poor terminal-to-pin connection. If there is continuity to ground, repair the short and verify. If there is no continuity, move to the final connection checks. If the test light stays off constantly during the control test, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, move to the final connection checks. If it is not below 3.0 ohms, repair the open or high resistance and verify the repair. For the final pass, inspect the related PCM inline and component harness connections. Disconnect the PCM connectors, any related inline connectors, and the related component connectors. Look for poor connector installation, damaged locks, corrosion, water intrusion, damaged weather seals, bent terminals, overheating from poor contact, pushed back terminals, spread terminals, and poor terminal tension. Repair anything you find. Then reconnect the PCM, inline and component connectors, making sure every connector is fully seated and locked. Erase the DTCs, operate or test drive the truck under the monitor in captured conditions, then read DTCs again. If P0304 does not return, the wiring or poor connection problem has been repaired. If it does return after this full connection check, replace and program the PCM, then verify the repair and confirm the code stays gone. The takeaway is simple. Prove the cylinder for misfire is active. Separate fuel, spark, air, mechanical, VVL, and wiring causes in order, and leave PCM replacement until the end of the path. For more diagnostic training, visit stepdiagnostics.com.